All right, here we want to calculate the density of potassium, which has a radius of 2.35 angstroms, a molar mass of 39.1 grams per mole, and it forms a body-centered cubic lattice. All right, so we're going to go to our work here. Body-centered is actually going to be this formula right here. And what we want to do is calculate the density here. So that's what we're doing. So pretty much straight density calculation. Density is going to be equal to, it's body-centered, so it has 2 atoms. So 2 atoms times, what's our atomic mass of potassium? It's 39.1 grams per mole. This is going to be 39.10 grams per mole divided by Avogadro's number, 6.022 times 10 to the 23rd. That's in units of atoms per mole. That's all going to be divided by this business, which is going to be 4 over, let's see, square root of 3, quantity cubed, and then times r cubed. All right, what is r? In this case, r is 2.35 angstroms. All right, so I'm going to say 1 angstrom is 10 to the negative 8th centimeters. This is going to be 2.35 times 10 to the minus 8th centimeters. This is going to be 2.35, make sure that number's right, 2.35, and it's times 10 to the minus 8th centimeters, and that's quantity cubed, and I should multiply all this out and get the density. So let's figure out what the density is. And notice how the units cancel. Atoms cancel, got an email. Notice that moles or per mole cancels, and I'm going to be left with grams per cubic centimeter. So let's go ahead and figure out what this is. I'm going to multiply it out. So it's going to be 2 times 39.1 divided by 6.022 times 10 to the 23rd. All right. Then it's going to be divided by this quantity. It's going to be, let's do 4 divided by square root of 3. And this, it's really important to get the parentheses right. Take some practice. And then we're going to divide by the quantity, 2.35 times 10 to the minus 8th. And that is going to be quantity cubed. And so for this, this has a density of 0.812. It's going to be grams per cubic centimeter. Now this one's going to have a lower density because it's an alkali metal. Alkali metals aren't known to have as much density. Okay, so this is potassium, so I wouldn't expect it to have much of a high density. It's pretty low. But hopefully that makes sense. This is again calculating density, and pretty much with these problems it's just plugging the numbers into the appropriate formula. So the hardest part is actually just knowing what formula to use. All right, in the next video we're going to do this problem.